Hey, what's up? Welcome to another video on secular measure. In today's lesson, we are going to tackle some challenging questions. The questions here might be difficult for the average student. Now, the first question I have here is question number 11 of 2020 May June from variant 22. So, you might have come across this question. Now, let's look at this question. Um, they say that we have circles with center C1 and C2, and the radii is of length R centimeters. So here's R. Now C1, C2 is a radius of both circles. Yes, that's what I've written here. The two circles intersect at A and B. A, given that the perimeter of the shaded region is 4 pi, find the value of R. So here, so what I can do here is I can connect A to C1. Have you heard of the word connect the dot? Here it's very important for you to connect A to C2 and C1. Otherwise, you really struggle with this question. I can do the same for this one. C1 to B and C2 to B. Okay. So here's R. Here's R. Now let me bring the R within this R. This is R. So this one to be R. This side to be R. Well, I don't need to write all of them. So if all your lengths are equal, that means all your angles are equal. In other words, what I have here is equilateral triangle. So that means my angle is for 60 degrees. And you know that 60 degrees is the same as pi on 3. This side to be pi on 3. Okay. So basically, what I've done is that I have something like this. My sketch is not that bad. So C1, then I have AB or BA. So now the angle here is pi on 3 plus pi on 3, which is 2 pi on 3. The radius I don't know, so I call it R. R. In fact, they say it is R. So what I've done is that I've just taken a portion. I've just taken one of the sectors. Okay. Now they told me that the perimeter of the shaded area is 4 pi. However, I can find the length of this arc. Okay. Now the perimeter is equal to 4 pi. Mind you, the length of this arc will be the same as the length of the arc here. Okay. And the length of the arc is rho. Don't forget. So since I have two of them, it will be 2 rho theta. So 2 rho theta is equal to 4 pi. Why did I shift it to that side? Okay. Now we know the value of theta. Theta is the same as what? 2 pi on 3. Okay. So this is the same as 4 pi r on 3 is equal to 4 pi. This one can be written as this. Now, did you know that numerator and numerator can cross out? Yes, they can. And denominator and denominator can also cancel. That's if both of them are fractions with an equal to sign separating them. Okay, so now r is equal to 3, 3 centimeters. That's it. So what I did was that basically I found the length of the arc. I found the length of this arc, this one. And since the other one here too is the same, because they have the same radius, they have the same angles. So that's what I've done. So twice the length of the arc. Now the B. Find the area of the shaded region. The area of the shaded region. Can I do something on this diagram? Now we know that the angle here is 2 pi on 3. This is a sector, can you see? Now when I joined A and B, on the bottom I have a segment. This segment is the same as that of the segment here, the same area. So right now what I can do is that I can find the area of the segment A, C to B and multiply by 2. So area of segment A, C to B. You know, segment is given by, this is the formula. What is your radius? Your radius is 3. Oh, it's just above my nose. Theta is 2 pi on 3. Now here they say the exact area. Don't forget the exact area. So that means your answer is a set. Leave it as a set. If it's a um it's in terms of pi, leave it in terms of pi. If it's a fraction, leave it in terms of a fraction. So they don't want you to use calculator here. So here I'm getting this value. Okay. Now since I'm looking for twice the area of the segment, this side is part. So I'll multiply by 2. Whatever I've got, I'll multiply by 2. So area of shaded region should be twice that of the one I have here. This is 9. 3 squared is 9. 2 pi on 3. Now, sine 2 pi on 3. This is the same as 2 times 180 over 3. This is the same as sine 120. So don't forget that sine 120 is the same as sine 60. In the second quadrant, we are in the second quadrant, you can see the angle is always between the hypotenuse and the x-axis or the base, like a right angle triangle. Now, in the second quadrant, sine is positive. Okay, now we know that sine 60 is the same as cos 30. Cos 30, which is Z3 on 2. So a little bit of trick in there. Z3 on 2. So that's what we have found. So now let me wipe this one. So in my mind, you should get 1 mark for being able to calculate this for this one, or maybe they award the calculation of the whole thing. Okay, so now let's do some cancellation. Now this will cross out this, so I'm going to have 9 by 2 pi on 3. So this should give me 6 pi. Then 9 by this, I'm going to get 9 say 3 on 2. You could have written like this. Either of them is correct. Okay, I can put it's in a bracket like this. It's an expression, centimeter squared. Let's look at another question. Okay, this one too looks interesting. This is question number 10. The reason why I'm rating these questions as difficult is that from question number 9, even sometimes from number 8, they are normally challenging. From number 9, 8, 10, 11, normally these questions are challenging. So it is basically rated by Cambridge as difficult because of by virtue of the number. It might be very easy for you, but for many students, this will be challenging just because question number 10. Okay, so now let's look at this one. So the diagram, we have a sector, and the sector is A O sorry OAB. OAB. So this is a sector. You can see, so that's a sector. What looks like the African map. That's a sector. Okay. The radius is 20. So if this is 20, this side should be 20. The perimeter of the sector is 65. Okay, so if here is 20, here is 20, here should be 25. This will give you 65 if you sum them up. CA and CB are both tangent. CA and CB are both tangent. Okay, that explains why we have 90 degrees here, because this radius and this is the tangent. Radius meet the tangent at 90 degrees. So they could have chosen not to have given you the angles A and B. Okay, so the triangle ABC is isosceles. ABC, ABC. Okay, that means that the length here is the same as the length here. Okay, AC and CB are equal in length. Yeah, because isosceles. So the base angles will be the same. All right, understandable. What happens? Then they tell us that angle AOB is theta. Okay, so now let's see how best we can answer this one. To start with, um, we can find the length of, we can find the angle here, theta. Why? Because the length of arc AB is equal to rho theta. Rho, not rho theta. Then we also know the length of the arc AB. AB is 25. The radius is 20. So theta is 25 on 20, which is the same as 1.25, or somehow will get 5 on 4. Okay, radians. So this should give you your first mark. Then look at this carefully. I can find, if I connect this, I pass a line through this side. What do I have? I have a, this is a kite because two adjacent sides are equal in length. This side and this side are equal in length. So if I draw a diagonal, this diagonal, if I draw a diagonal through this, the diagonal should bisect my angles. So if the angle at this side is 1.25, if the angle is bisected, what am I going to get? When I bisect that angle, what am I going to get? So let's take the calculator and calculate it quickly. 1.25 divided by 2. Okay, so I'm getting 0.625. All right, 0.625. Okay, so if I know this, I can find the length of my diagonal. I can find, yes, I should be able to, because right now I have a right angle triangle. I'm just turning the shape for you to view it properly. So here is O, here is 90 degrees, that's B. This side is C. Okay, so, and I know the length here to be OB is 20. The angle here is 0.625. So I can easily find OC by using, so let me cut and paste here so that I want to find the length of OC, which will be the length of my diagonal. So I can apply cos, the cos ratio. Cos of 0.625 is equal to 20 on OC. So OC should be 20 on cos 0.625. So calculate this one for me. Let's see what you're going to get. So OC is giving us 24.66. 24.6. You can correct it to three significant figures. So here is 24.66. Okay, I can also find the length here at this side. Don't forget, you have something like this. This is A, this is B, this is O. Your angle here is 1.25. This is 20, this is 20. So I can apply the cosine rule here. Okay. So from the cosine rule, uh, considering triangle, I'm considering triangle what? You are talking to the examiner, so make sure that your presentation is very good. A O B. Okay. Triangle A O B. So can I say that AB squared is equal to 20 squared plus 20 squared minus 220 times 20, which is 20 squared, cos of the angle 1.25. I can find the square root of both sides. So now let's calculate that and see what you get. I'm getting 23.4.40, which is the same as 20.4 for AB. So right now I can find the area of the kite. Okay. So the area of the kite is this kite A O B C. You can bring back to the original, so A. Yeah, okay. I've labeled my kite. So kite is half of the product of the diagonals. So the diagonal is AB and CO or OC. AB is what? AB is, we just found AB to be 23.4. OC is what? OC is 24.66. So now let's multiply this and see. Getting 288.522. You don't need to approximate here or correct to three significant figures here. You can do so. You can do so later. I mean, your final answer. That's where it's appropriate for you to do that. So I found my area, the area of the kite. I can adjust my writing, my font size. You cannot do that. So don't follow me. Be careful. Now, finally, it's left with the area of the sector. So I can find the area of this sector. Area of this sector. Area of the sector is of sector. Which sector are you talking about? You might have more than one. So area of sector AOB. Hope you remember the formula. Your radius is 20. your angle is 1.25. So if you calculate for this, what are you going to get? I'm getting 250. Okay. So now the shaded area is the area of the kite, which is 288.522 minus the area of the sector, which is 250. So subtract this for me. Let's see what you are going to get. So I'm getting 38.522. So 38.5. This is my answer. So you have seen that circular measure is not difficult actually. This was one of the challenging questions, but it will be difficult for you if you don't solve questions. So I encourage you to go over the video, practice the question yourself without referring to the solution, and I will meet you in the next one. Have a lovely day. Bye.